All right, let's talk about something every developer has to build sooner or later, file uploads. Today, we're focusing on how to do it in Flask. And, what seems super simple on the surface? Well, it turns out it's packed with all kinds of hidden traps.
I mean, seriously, how hard can they be, right? You just slap an input field on a form, the user picks a file, you hit save, done. That's kind of the first thought for most of us.
But oh boy, you'd be surprised. The truth is, if you get this wrong, a simple file upload can become the single biggest vulnerability in your entire application. We're talking major security holes, denial of service attacks that bring your server to its knees, just all around bad news. So let's figure out how to do it the right way. Okay, so let's start at square one. We're going to build the most basic file upload you can imagine, the kind of thing you'd see in a Hello World tutorial for Flask. So here's how it works. When someone submits a form, Flask neatly tucks the uploaded file away in this special object called request.files. From there, it feels almost too easy. You just grab the file from that object and call a save method to pop it onto your server. It feels wonderfully, deceptively simple. But here's the million-dollar question. Is it actually safe? Because this simple, clean approach, while it works, well, it leaves our server completely exposed. The file name, for instance, comes straight from the user. And if there's one rule in web security, it's that you never, ever trust user input. And that brings us right to our first huge problem, locking down the upload endpoint. Just saving a file as is, without any checks, is basically rolling out the red carpet for disaster. And the ways people can mess with you are kind of terrifying. They could upload a malicious script, say a PHP or HTML file, hoping your server is misconfigured and just runs it. Or they could use these really clever file names to try and crawl through your file system and overwrite critical files. Or they could just go for brute force, bombarding you with massive files to chew up all your disk space and crash the server. Or even worse, use your app to spread malware to your other users. It's a minefield. This is exactly why our first line of defense is so absolutely critical. It's a function called secure file name. And just look at what it does. On the left, you see an attacker trying to be clever, using .. to navigate up the directory tree to overwrite a really sensitive file. But you run it through secure file name and poof, all that dangerous stuff is stripped out, leaving a perfectly flat, safe file name. Using this is completely non-negotiable. But, one function is never enough. Real security is all about layers, like a castle with multiple walls. So after sanitizing the file name, you should absolutely have a whitelist of extensions you allow, only things like JPEG or PDF. Then you got to check the file's actual contents, its MIME type, because anyone can rename a virus to mycutecat.jpg. Next, you set a hard limit on file size right in your Flask config. That shuts down those storage exhaustion attacks. And hey, if you're building a really high-risk app, you might even integrate a virus scanner. Each layer closes another potential door for attackers. Okay, so our endpoint is secure, we're feeling good. But what happens when a real user tries to upload a really big file? This quote from a developer on Reddit just nails the next big problem. The default setup literally eats all memory away. Your server's memory usage just climbs and climbs with the file size until, boom, it crashes. And this leads us straight into our second major challenge, how to handle large files without blowing up the server. This is where we have to get a little more sophisticated than the default behavior.
So what's actually happening behind the scenes to cause that massive memory spike? By default, Flask tries to be helpful by loading the entire file into your computer's RAM before saving it to the disk. For a small photo, that's totally fine, super fast. But for a 1 GB video file, yeah, that's a recipe for a server crashing disaster.
The solution here is really elegant. It's called file chunking. Instead of sending one giant file in one giant request, the browser slices it up into little manageable pieces before sending anything. Think of it like this. Instead of trying to mail an entire encyclopedia at once, you mail it one page at a time. Your server gets each tiny chunk, appends it to a file on the disk, and your memory usage stays nice and low and flat, no matter how huge the upload is. It's a total game changer. So we can upload files securely. We can upload them efficiently.
even if they're massive. Awesome. But where do we actually put them for the long term? This is the final piece of the puzzle, your permanent storage strategy. You've really got three main paths here. First, the local file system. It's simple, it's the default, but it's a real pain to scale across multiple servers. Then there's the database. It's tempting to just stuff the file data in there with everything else, but this can absolutely destroy your database performance. That's why for most modern apps, the answer is cloud storage like Amazon S3. It's built to be incredibly scalable and durable, and it cleanly separates your file storage from your application. That's almost always what you want.
All right, we've battled through security, we've tackled scalability, and we've picked our storage. Let's pull all of this together into one solid blueprint that you can use in your own project.
So here it is, your checklist for a rock-solid file upload. For security, always sanitize file names, validate the file type in 2 different ways, and enforce a strict size limit. For performance, use chunking for anything bigger than a few megs, and choose a storage strategy that can actually grow with you. And for just good, robust code, make sure you can handle multiple files at once, and for goodness sake, have graceful error handling for every single thing that could possibly go wrong.
And that brings us to one last thought to leave you with. Okay, you've built this bulletproof backend. It's secure, it's scalable. Fantastic. But what about the person on the other side of the screen? A truly great feature doesn't just work well, it fails well. It gives clear, helpful feedback when something goes wrong. So think about it. When that upload inevitably fails for some reason, what does your user actually see?